definitely. So I can go up, and because it wraps around itself, I'd end up here, and then 0. And from here, I can't go anywhere up. So this is where my algorithm should output the end, right? That's what it does. So here, it started here, it goes right, down, left, up, and show. So the output should show that this is the final place we can get to. Same thing here, but this is a slightly more complicated one because we're doing, the wrapped part. So this is where I'll end up. And essentially, we just want to create this program. But as I said, we're going to do it step by step. So just showing you the inputs and the outputs, right? If we start it over here, we end up over here. If we start over here by using this nice thing of wrapping around the walls, we eventually end up here. So constraints, there will always be one single route, connected pathway, so no loops, no branches running from the car's start location. Now to do this, especially the part about the wrapped walls, there is some math that we need to do. So we'll start with some math problems. Firstly, while the length of to do is, because remember, we keep repeating this, while the queue is not empty. So while the length of to do is actually greater than 0, so while there are still elements in the queue that we need to process, I'm going to keep going. I get the first item in the queue. So who can remind me what the function we used in Python was to remove the first item in the list? That allows me to remove it and return it. So I could do first equals to do dot something, and that would remove it in the list and allow me to put it into the variable called first. Does anyone remember what it's called? All right, so it was called pop first equals to do dot pop. This removes the first element from the list and make sure we put the index. So pop 0, that means the first element of the list. It removes it and it helps me place it inside this variable called first. Our homework from last week was actually consisted of one GCSE fast question, one IGCSE fast question. So both really important questions. First says, we have an incomplete Python program here to create a bingo ticket for a player. And the programmer has used a 2D array called ticket to represent this bingo ticket. The program uses a subroutine called generate key term, which when we call this subroutine, it will return a random key term. So for example, CPU, ALU, NOT gate, etc. What we need to do is complete the Python program in figure 16 by filling in the 5 gaps. Line numbers are included, but are not part of the program. So we're going to go through this code, figure out what the missing pieces of code are, and then fill in those 5 blanks. So exactly as we saw in last example. What I'm going to do is I will give you 3 minutes to have a go at writing the function and then calling it inside the loop and then trying it out with your matrix to see that it does actually give us our products. I will send you a link now, Kuna, if you don't have access to the Python editor. So we use this very nice Python editor. I'll send you the link in the chat, and you don't need to log in or anything. Just click on products at the top and click on the text editor. So let me show you how exactly we do that. So if you go to nencode, it does ask you to log in, but you can just ignore all of that. Go to products and then Blockly Python editor at the top here. And then to make it just Python, click on text, because we don't want the blockly for now.